Welcome to Social Developers Club. Who has never been on a meetup before from us? 2, nice. Okay, so there are rules. Just kidding. But yes. So we're Social Developers Club. We had just in March a really big conference here at this location with around, well, super big not, but 200 people, and it was super fun. We are already in the planning for the next one. And this is also what we do. We are an inclusive tech community beyond code that makes technology accessible to all. This is our vision, and this is what we do. And we do this by hosting meetups like tonight, so the community can get to know each other. But we're also having workshops, usually with kids and students, together with Goethe Institute or Hacker School or Körperstiftung. So yeah, education, the next generation. And then we also have the conferences, which are also focusing on workshops during the day, but we also have one main stage. And yes, our next meetup and last meetup before the summer break, because you can see it's super hot outside, so people don't really enjoy staying inside. But thanks for joining today. The next one will be at Moja about autonomous driving. I think that's going to be super fun. It's already in 2 weeks, so exactly 2 weeks from today, and I hope to see you there as well. Also, this is the only rule actually we got, that's the Pac-Man circle, and this just means after the talks and presentations, if you hang out together and talk and speak, you probably stand in circles, and we always want to make sure that we keep a little gap in the circle, like the Pac-Man mouth, so anytime anyone can join the group. Yes. And also we are taking pictures and videos, like you see there's a live stream going on, and I will take some pictures from the back. If you don't want that, let me know. You get a little sticker from me, and then everyone knows that you don't want to be on pictures. And I think that's about it. Yeah, we have this super new WhatsApp group where we share all the news about the community, all the events that are happening, but you can also find us on Instagram or LinkedIn or Discord, Twitter, yeah, actually everywhere. All right, if you have any questions about the community, let me know afterwards. And now I'm giving the mic to Chris, who's sharing, I'm sorry. Victoria, our first speaker, is sick today, so that was actually the intro part of this evening into game development. And Chris is the second one who's going dive deep into the topic, but that's fine. I think you're all smart, but please feel free to ask questions all the time because we are jumping right into the topic of game development. So, welcome to the stage.
Thank you. Hi. Yeah, welcome to the SAE Institute. My name is Christoph, and I am the academic coordinator here in Hamburg. And yeah, so I'm going to talk about game development. I didn't prepare slides, so I decided to just scribble around in Windows Microsoft Whiteboard to illustrate the topics I will be talking about. So my background is that I have been the head of the games programming department for about 12 years here at the SAE in Hamburg. So I educated a lot of students about game development, the programming part, the production part, the design part, a bit of the arts part. So, and as you might be able to conduct from that, game development is like a really, really big mess of departments and topics. And yeah, so our pardon verloren. So basically what we try to do as the development side is to keep everything together. So yeah, games, if we want to do games, there is a a lot of stuff we have to consider. First of all, we have, of course, to consider the programming part. So without programming, there is basically no game. But with only programming, we would have games that probably will work, but they might not look as pretty. So besides programming, we usually have like the arts department. So the guys and gals who do the 3D models, the sprites, the 2D stuff, the animation, everything basically you can see in the game. This is what the artists do. It's rather hot. Okay, so programming and arts is fine. What we also need is an audio department, because we also want to have our games sound interesting or nice. And to make those fun, we also have the design department. A lot of people tend to confuse arts and design. So the distinction we make in the game development is that the art department is doing all the visual stuff, and the design department is usually about how the game plays, how the game feels, and so on and so on. So if you ever have played a game and you liked it, that's probably because the designers did a good job. If you didn't like it, it's probably also the designer's fault. Or if you have like encountered bugs, that's probably going on us. Or another important department we usually have is a QA department, which does all the testing during the production, and when the production goes on until the release. And yeah, that are the 5 most important departments when we do game dev. And we have to basically work or make them work together somehow. And that can be really, really difficult. But on the other hand, it can be really, really interesting and nice to work, because doing games, never grows langweilig? Boring, yeah. There is never a boring day in game development, because you have to do a lot of different topics, you have a lot of different tasks, and yeah, so. Okay, so that's the departments. Usually, we have, within the departments, we have the programming department, which consists of probably the most people. Then the art department is basically the biggest department, because we have to do lots and lots and lots of assets. We also have to do a lot of programming, but nice for us, we don't have to do it all on our own. So we live in a time where making games is rather easy, because what we use to make our games are so-called game engines. So maybe you have heard of some. The most well-known are Unity, Unreal, and maybe Godot nowadays. So, yeah, these engines, especially those two, they do the heavy lifting for us. They give us all the tools we need to make our games work. Yeah, so they give us the tools we need for making games. We need a lot of tools. For example, we would need to make our game run, we would need some renderer. This means something that makes displaying the images on the screen possible, to do all the nice effects, to do all the 3D stuff and the animation stuff and the lighting stuff and so on and so on. We also need some physics component for detecting collisions and handling collisions. Those two are probably the most important parts of a game engine, because we have to do a lot of rendering. For example, if we are talking about AAA games, we want to render an image pretty fast. So we are, basically what we want to achieve is 60 frames per second. So 60 images per second on our screen. Nowadays, also, people want to have 120 FPS. Or if you want to do VR stuff, you also need 120 FPS because you need 60 for the left eye and 60 for the right eye to have a smooth image and make people not motion sick or nauseous. So as you can imagine, putting 120 pictures on the screen each second is hard. You have to really know your stuff to make this happen, especially if you want to have like AAA graphics with a lot of models and a lot of effects and a lot of animation going on, and so on and so on and so on. You don't have a lot of time to put your picture on the screen. So what AAA studios tend to do is they try to limit the frame rate to about 30 FPS, and they call it cinematic experience. So there's a big discussion within gamers about frames per second. Hardcore gamers need probably 60 FPS or 120 FPS. If your game only supports like 30 FPS, there is a good chance you will get shit-talked on Steam reviews because you are a lazy programmer and you are not doing your job right. So, yeah. You should at least be able to put about 20 FPS on your screen in your game. Lower than 20 frames per second, your game really tends to stutter and basically not play well. So if some of you are old enough to have owned a Nintendo 46, you probably know that, because a lot of Nintendo 46 games ran at 20 or 12 frames per second, because Nintendo isn't the company to put like cutting edge hardware into their devices. So yeah, this was a big complaint about the Nintendo consoles in general. So 60 frames per second. We have to do a lot of rendering, like I said. There's a lot of stuff to be calculated, especially if you want to have like photorealism. So AAA games also are famous for like putting out really, really nice graphics, really realistic graphics. And as you can imagine, it's difficult to calculate all the lighting stuff and so on and so on and so on. Also same with physics, because I mean our game, when you are in a game, you should feel like you're actually in a space that exists. So there should be walls you cannot walk through. There should be crates that fall down. There should be stuff you can run over, and so on and so on and so on. Yeah, that's also really tricky because if you have like a lot of physics objects in your game and they all should behave in a certain way, that also needs to be calculated somehow. We need physics for basically everything, for checking if our player is on the ground, if they walk through a door, if they collide with a table, or if you have like a first or third person shooter, you have to check if you actually hit your target. And maybe you want to make a distinction where you hit an enemy. So physics also really, really heavy on the calculation side. And doing those right is a pain in the ass. So if you want to do this on your own, go have fun. You will probably spend all your time setting up your own engine and never make a game. So, but I mean, that's what we had to do like 20 years ago. So everyone had to make their own engine. Everyone, yeah, had to like reinvent the wheel over and over and over again, and so on and so on. Engines did exist back then, especially the Unreal Engine. It's a really old engine. It's from the late 90s. The first version of Unreal Engine was released. And what you had to do back then is, if you didn't want to do your own engine, you had to buy one. And that was really expensive. For example, the Unreal Engine or the Cry engine, which is also like a well-known engine, which was actually developed in Germany by Crytek. So if you wanted to license one of those engines, you had to put up a license fee from about $1 million. So, I mean, if you have $1 million, fine. If you don't have, maybe you were thinking about, okay, I can do my own engine. That all changed with the advent of Unity. Unity started as a game engine exclusively for Mac, which is kind of ridiculous when you think about it, because nobody does games for Mac. So developing games was always for consoles and for PC mainly. Yeah, but what they did, they made an engine for Mac. Okay? But as you can imagine, as I've said, making games for Mac isn't like a big business, so they, of course, also made a version for PCs and for Linux. And what they did is they gave their engine away for free. So Unity was one of the first like engine developers. Basically, what they like to call is democratizing game development, because they just gave you the engine, you could use that, you didn't have to pay like royalty fees or something. You could just download it, make a game, and earn money with that. A lot of people liked that really, really well. A lot of people started game development using Unity, especially indie developers. So, yeah. Indie development without Unity wouldn't probably be possible. That was nice. Since a lot of people started using Unity, I mean, all the other engine manufacturers thought, oh, okay, so if there is an engine for free and people will use this engine, why should they use mine engine? And people didn't use like Unreal Engine or other engines as much as Unity. So Unreal started to also go free. And they actually went like one step further. They open sourced the whole engine. You can download the whole source code for the Unreal Engine on GitHub, totally for free. You can make changes to the engine if you want. And you can basically download the code, compile it on your PC, and do something with Unreal. So that's the difference between Unity and Unreal. Unity is not open source, but Unreal is completely open source. You can actually, if you think that you have like a better solution for their rendering stuff, or for their physics stuff, or for their UI stuff, you can actually like suggest your change to them, and they will review it, and maybe they will incorporate it in a later version. And that's super interesting, because coming from like, okay, give us $1 million for the engine, to, okay, here's the source code, go have fun with it, that's a really, really big step. What might have helped Unreal is the shitload of Fortnite money they are making each day. Because Fortnite is made by Epic. Epic is the studio that does the Unreal Engine. And with Fortnite, they had tremendous success. And basically, they sit on a pile of cash. So that is probably one of the reasons Epic is able to provide Unreal for free. Because they have, money. And I mean, we don't complain. As I said, they are for free. That's only half true. You can download those engines for free. You can use them up to a certain amount of revenue you are getting each year. And then Unreal and Unity opted for a revenue share model. So if you pass, I think with Unity, it was $200,000 a year in revenue. You have to, well, first you had to get a pro license, which was $100 a month. So, I mean, if you have a revenue of 200,000, maybe you can afford like 1,000 per year for the engine, hopefully. Unreal opted for revenue share. So I think they get 5 to 10% of your revenue if you pass a threshold of, I don't know, maybe $1 million or so. So for smaller studios, maybe for a lot of indie studios, it's basically for free. So, or at least you have to change to get your game started and to earn money before you have to pay money back. So those are the two like main actors in the game development scene. Unreal tends to be used more for. So where do I have space? Let's go down here. For what we call AAA productions. So a lot of production value goes into those games. Basically blockbuster games like Call of Duty, FIFA, Fortnite. Like basically every big game you might know or might know from, I don't know, friends and so. That's what you call AAA. Interestingly, there is also a AA, but we don't use that term very often. This is for like mid-ranged games. There is no A. But what we also have sometimes is what we call triple I. And triple I is basically something like double A. These are indie games with a lot of production value. So if you don't have like your one-person show indie game, if you have an indie game like Stardew Valley, for example, which is a small game but has high production values and has a lot of success on Steam or on consoles, we call that triple I. But I mean, all of those are pretty fluent. So maybe someone will call it double A, someone will call it triple I. There's also the discussion what even is an indie game. So is an indie game something with a 2D pixelated art style? Is an indie game something that doesn't have like a publisher? Is an indie game a company that is independent? That would also make Epic an indie developer somehow. Or Electronic Arts or Microsoft, but nobody would consider Microsoft an indie developer. Yeah. So, so Unreal tends to be used more for the AAA productions because that is where Unreal is coming from. So Unreal was made in the late 90s for AAA productions, and then the Unreal Engine 2 and 3, and now 4 and 5. They were, or still are, tools for professionals. So if you're working with the Unreal Engine, Unreal kind of wants you to know your stuff to get the most out of it. Whereas Unity is the other way around. Unity is just, okay, you want to do stuff, okay, do stuff. And yeah, just do some code, maybe copy-paste some code from our forum. We will make it run somehow. Just have fun making a game. Yeah. So, yeah, then, yeah, Godot is pretty new. Not a lot of people use Godot, not yet. They made really big steps towards like being a proper usable engine in the last year. And since Unity did fuck up a bit last year too, a lot of people switched from Unity basically to Godot. Some of them switched to Unreal. Yeah, but it might take a while until Godot actually is ready for bigger productions. Another thing that is probably, or Unity or the indie developer were rather thankful is, if we are talking about the engines, like I said, they do all the heavy lifting for us for the rendering, the physics, also the inputs, and the exports, and so on and so on. The way we as developers work with these engines is we use code. Unity uses C#, which some of you might know. C# is, I mean, it's a pretty good language to start programming. And in combination with Unity, it's easy to get a start in game development because you have a nice language, you have a lot of possibilities also with Unity. The Unreal Engine uses C++, which, if you have worked with C++, you know C++ can be a bit of a pain. I mean, also gives you a lot of possibilities, but you have to know your shit. starting with C++ and the Unreal Engine probably will drive you mad. And Godot actually, I think they have C# support, interestingly. Pardon? Unity. They work with C#. Yeah, but Godot also, I think. And they have something like, I think they call it Godot script, which looks a bit like Python. Yeah, but yeah, you have a lot of possibilities to get started, and so basically there's an engine for everyone. What those engines also offer, which make them really, really interesting for newcomers, is something we call visual scripting. So there are basically all those engines have a no-code solution that enables you to work with them. And this is super for people that have never written a line of code in their life before, because what they do is basically they have a node system, and you can just connect the nodes you want, and you can do everything you can do in code, you can do in those nodes. This is pretty neat. Also, this is pretty neat if it comes to working together, because artists usually don't know how to code. They don't have to. I don't know how to do 3D stuff. So, but what enables, what they are able to do now is, if they have like an idea for a little feature they want to implement, or if they want to trigger like an animation in the game, or if for also the audio department and the design department all are able now to do stuff on their own. So if they want to, like I said, trigger an animation, or if they want to, I don't know, make a door go closed and open, or if they want to change like the height that the player is able to jump, they can do this within this node-based system with scriptable or with visual scripting, and they don't need a developer to do that for them. So the developers can concentrate on other stuff. They can concentrate on implementing some sort of system. We need some sort of, I don't know, maybe a skill tree or an economic system, or I don't know, anything we as programmers would do. So what's visual scripting enables us is to work in parallel, which is really nice for the whole process, because developing a game tends to take its time. So for a AAA production, you would look at a time frame of about maybe like 5 years, 5,000 people. An indie game, maybe 1 year, 2 years. So that's a lot of time. And if you can speed up the process by working in parallel, that really can help finishing the game faster, or making better game in less time. So I think this was the stuff Victoria, to a degree, and I wanted to talk about. So I mean, we are there. Sorry. I mean, we could open up for questions now, I guess. And if you are still interested after the questions, I could tell you some more about game development. Yeah.
Sounds
So,
good.
questions?
For the live stream, I would give you the mic.
Okay. So have you used visual scripting to develop a full game from start to finish?
I haven't used visual scripting for a whole game because coming from the development side, writing code is easier for me. But what I did do, or what we did in past productions, is give the artists and the audio guys and the design guys like a crash course and show them how to like integrate their visual scripting stuff with our written code. Yeah. So,
Right,
I know from our 3D and animation students that they do whole games just using Unreal scripting, visual scripting.
Oh.
So they put together whole games just with visual scripting.
Right. Okay, because I would have thought that debugging is a lot more difficult if you don't know how to code, and visual scripting is fine, but it's probably you don't know where to look. I guess.
For me, debugging visual scripting is hell because I like to do my breakpoints and look at my code and find the error there. But for people that are not familiar with that kind of debugging, so they seem to get along pretty fine with the visual scripting stuff because what you also have in those node-based systems, you have like visualizations of where your code is and which node is triggered and where your code base. So the visual scripting tools give you like visual indicators of where your code is. So you can follow the code around through the nodes and you can do breakpoints in your nodes. So it's basically the same, but on another level. And people not familiar with how developers debug, I mean, they manage, they do fine. Right. I mean, I'm flabbergasted by that. But yeah, I think coming from a development background, we would be faster doing it our way. But yeah, it works.
Okay. I would have another question.
Yeah.
When we do workshops with especially young students or kids, we always, for example, last year we did a lot of 3D modeling, and they always asked us, can we do something in Roblox or Minecraft? What's your take on that? Is that like evolving strongly also in the more advanced gaming industry?
I mean, Roblox is great for teaching people how to code because it's basically what Unity and Unreal do for people with experience. Like Roblox gives you the opportunity to do it within an environment you already know. So this is always, in my opinion, like really helpful for learning stuff if you are in an environment you know. I mean, Roblox, Minecraft, also to a degree, Fortnite. I mean, there's a separate version of the Unreal Engine for Fortnite. So you can do like Fortnite stuff in Unreal. And if you have like played Unreal, if you have like played Fortnite, a lot, you feel familiar with that. And yeah, I mean, basically it teaches you coding. If you write code, if you click together some nodes, it teaches you the mindset of coding basically. And if you got that mindset right, or if you have an understanding of the concepts, I mean, the next logic part maybe is writing code yourself, but yeah, it can be an easy entry of barrier to get into coding.
Do you have maybe also more tips on how to get started in game development? How can we all be the next generation of game developers?
I mean, download one of the engines you like and get started. There is a lot of tutorials from Unreal, from Unity, from Godot. A lot of creators out there do really good tutorials. And basically, yeah, come up with an idea, get your engine, and go have fun.
And what's like the minimal hardware setup we need to have?
I don't know if you have like a 10-year-old PC, that is fine. Depends on what you want to do. If you want to do like a AAA game, maybe not. Maybe you would have invested into a gaming PC and like a graphics card that can do ray tracing and stuff. If you want to do a small 2D pixel game, anything that runs Windows is fine. Anything that has been running Windows since the last 15 years is fine. Just go ahead.
Nice, thank you. Are there more questions? No. All right, then thank you very much. And I would say we have some more drinks left and a couple snacks. Feel free to stay a little longer. We'll have like an hour left to stay at the location and yeah, get to know each other and think of Pac-Man. Really fitting for today. Thank you.